Now let's see the next question. 4 boys and 4 girls are to be seated in a row such that no 2 girls are together. In how many ways this can be done? Now to solve this type of question, let us draw a diagram like this. That is, since we want no 2 girls to sit together, let us first consider the 4 boys denoted by letter B. And hence, if we want no 2 girls to sit together, then the only available places where the girls can sit are the places in between the boys and on the both extremes. So now let us first count in how many ways the boys can be seated. Now we can see that 4 boys and 4 positions. So therefore total number of ways to arrange the boys are nothing but 4 factorial. Now on the remaining 5 places there are 4 girls to be seated. So therefore of course one of the position is going to remain empty. Now therefore we have to first select the 4 places out of these 5 places. So therefore that can be done in 5C4 ways. So these are the ways of selecting any 4 places out of the 5 places. Now having done that, the 4 girls can permute within themselves in 4 factorial ways. So therefore this is the total number. Now if you look at this particular expression, that is nothing but the expression of 5p4, and 4 factorial is nothing but 24. So therefore on simplifying we get 24 into 5p4 is nothing but 5 factorial whole upon 5 minus 4, which is 1 factorial, which is 1. So therefore we get 24 into 5 factorial is nothing but 120. Therefore the final answer is 2880. Let's move on to the next question. How many words can be formed using the letters of the word logarithm if vowels are always adjacent to each other? So now here if we see the total number of letters present in this word are 9, out of which the vowels are O, I and A. So therefore there are 3 vowels, hence the remaining 6 letters are nothing but the consonants. It's given that the vowels are always to occupy the adjacent places. So therefore let's think of a box in which 3 vowels are sitting. So therefore A, I, O. Let's think of a box as 1 unit. Now other than the vowels there are remaining 6 consonants. So we can think of them as 6 units. So in total there are total 7 units. Now these 7 units can arrange among themselves in 7 factorial ways. And for each of this particular arrangement, if we think of the vowel box, the 3 vowels can arrange among themselves in 3 factorial ways. So therefore we have to multiply 7 factorial by 3 factorial, and that is the final answer. So these many total words can be formed in which the vowels are always together. So no matter where the box is present, the 3 vowels A, I and O, they are always adjacent to each other. Let's go on to the next question. How many different words can be formed using the letters of the word Mississippi? Now here if you observe, there are a lot of letters which are repeating. Specifically if we see the I is repeating 4 times, and so is the letter S. which is also repeating 4 times. Then if we see the letter P is repeating 2 times and M is coming only once. So basically 3 letters are repeating. In all there are total 11 letters. Now if you think that if these 11 letters were different, then they would have given rise to 11 factorial number of permutations among themselves. But since there are repeating letters, the total number will get divided by the corresponding factorial. So therefore our final answer is 11 factorial divided by 4 factorial, further divided by 4 factorial, and further divided by 2 factorial. So that is the total number of words that can be formed using the letters of the word Mississippi.